Good morning, everybody. How's everybody doing? Hopefully not a horrible weekend. Hopefully you guys had a good weekend. Played hard over the 4th. Busy, busy. That's good. Busy is good. Ashley, if you can hear, yeah, you texted in still. Yeah, no worries. Just text when you can, or if it starts to work, try shutting it off and turning it back on again. That sometimes works. Studying hard. That's good, Jen. Yeah. Yeah. Pain in the patella, but yeah, I get it. Okay, so we actually got a lot to get through. I can't believe we're already in week 6, but we are flying through this semester. There's only basically 3 weeks left of class. Um, that's not a lot of time, and we have to get through the digestive system, the urinary system, and the reproductive system in that period of time. So here's where we're at. We actually didn't finish everything in class on respiratory. You guys might recall that there was, let me share my screen here, that we didn't finish up the 4th lecture. Now, here's the deal. I don't typically like to do this, but I kind of have to do this, is that there's a narrated PowerPoint, and I want you guys to be using this as your primary source of studying the respiratory control. In addition, I want to remind you guys that I have YouTube videos for everything. Oh, come on. Yeah, for ventilation, for gas exchange and Fick's law. Don't mind the ventilation one. I didn't even know that there was night vision on the camera when I did it. For O2 CO2 transport, I was literally my very first. This is right when the pandemic hit. So this was my very first YouTube video. I had no idea what I was doing. I still don't. Let's be honest. Let's see here. O2 CO2 transport, which we talked about last week, but the one that we didn't get to are respiratory control centers. And let me remind you how important control centers are to me. They are homeostasis. Without proper control centers, primarily found in the brain, right? We wouldn't have all of these wonderful reflexes that we have. They just wouldn't exist. So you guys definitely need to study it. You need to pay close attention to it. It's not just me saying that. It will be on the exam, and it will be on your comp final, guaranteed. And it's going to be part of the renal system, oddly enough. Because if you recall what I said earlier about the respiratory system, is one of its functions, it's not just ventilation and gas exchange, right? Another one of its functions is it controls 70% of all of your pH balance, of your blood acidity. That's a pretty big deal, don't you think? Considering that acids cook proteins, we better be paying close attention to what's going on with them. And so this ventilatory, respiratory control centers, they are what are going to get triggered. And it's all going to be due to, yeah, you got it, Tariq. You've kind of already looked ahead on it. Thank you. It's all going to be due to that whole conversion of CO2 plus water make carbonic acid. So let me just ask you guys this now. Let me not just ask it. Let's just say it. Carbonic acid is the #1 source of acid in the human body. There's nothing else that even compares. Carbonic acid is the #1 source of acid in the human body. Everybody, what's the #1 source of acid in the human body? You guys got it. And Tariq, don't abbreviate it CA. I know why you did that. I'm just trying to help you guys so you don't mess it up and call it CA on an exam, because CA is carbonic anhydrase. Yeah, anhydrase. But yeah, exactly. We don't want to get those two mixed up. Sound like a plan? All right. So please watch these. What I did for y'all is I put a respiratory YouTube vids link on the Blackboard. So now you have all those links easily accessible. You don't have to go searching for them in case that's what you were doing. Of course, you could just have saved my YouTube video channel earlier. And there we go. Is everybody clear? Respiratory system control centers will be on the exams. And if you have any questions about them whatsoever, just holler my way. They are important. Like things like CSF is rich with carbonic anhydrase. What does that tell us about the consumption of CO2 in cerebral spinal fluid in the brain? There's a lot of carbonic anhydrase, then the brain is going to be consuming a lot of CO2 and converting it into acid. Well, we better be able to monitor for that. We're not actually making it into acid on purpose. We need the bicarbs. But it's all part of the bigger scheme of things. No, it's not because cellular respiration's high. That's because it's high in carbonic anhydrase. It's converting it all to carbonic acid, and then that is going to dissociate in water and become hydrogens and bicarb. CSF is very rich buffering system. So now the brain's got to figure out what to do with all those acids. One of the things it does is it monitors them using chemoreceptors. That's monitoring for acid content. The more acid there is, what do you guys think is going to happen to your breathing? We're going to want to breathe more, or we're going to want to breathe less? Increase, decrease, no change. The more acid that's in the system. Remind you, CO2 is the #1 source of acid in the human body. So if your body is too acidic, one of the things it can do, we're going to get to this more next week. All right? One of the things it's going to do, end of story, is you're going to breathe faster. You're going to get rid of CO2. Even if the source of acid is ketonic acids, you're still going to breathe faster to get rid of CO2 because homeostasis, because physiology. All right. That's all explained in the YouTube video and in the PowerPoint. So please take your time and watch those. They are important to your education. And I am here to go through them with you guys during office hours. I just can't waste more. Waste is a bad term for it, but I just can't use more lecture time because we have digestive system all to get through before Sunday's exam. So digestive system anatomy, in case you guys hadn't seen, I posted all these YouTube videos. Yeah, Tariq, absolutely, bud. That's what they're for. Office hours, and then outside of office hours, you just got to contact me and let me know. Yeah. Well, I don't just sit there and wait in my office hours. It's not like, you know, if I was in a school situation, I'm not just going to sit in my office. So just text me. Just text me and just say, yo, Dr. H, office hours. And I will figure out, you know, put the kids in a kennel or something like that, and they'll come on up. I won't really do that. I got all the digestive system anatomy all here. So you guys, for lab tomorrow, tomorrow's going to be pretty crazy. It just seems like a reoccurring theme though, right? Tomorrow you guys are going to be both digestive system anatomy, which is a huge amount of material, and you're going to be doing renal system anatomy, which is a little bit smaller and a little bit easier to get through, but it's definitely going to take time. Yeah, that's my little Aniston. You guys have seen her this semester, all grown up now. All right, cool. Now you guys are aware that all this exists. I know, she's that dang baby's growing and stuff like that. All right, so digestive system, the anatomy lecture, I still do not have a narrated PowerPoint for. Everything else that I do. Okay, so what's the function of the digestive system? It's a silly question. Or is it? Break down food, deliver nutrients. Keep going, guys, keep going. Oddly enough, nobody's gotten it fully yet. Break down stuff, get rid of used food. Oh, we'll get there. Keep going, keep going. Think about this. Rest and digest. I love it. You gotta be thinking about the parasympathetic nervous system when you're thinking about this. Yep, for sure. So this is the problem. A problem. Yeah, I love, Parker, that you went to glucose, man. Turn food into energy, energy for ATP. That's a great understanding of the digestive system. Obviously, there's a lot more because you're digesting vitamins and all that sort of stuff as well. But here's the deal. When we think of digestion system, most of the time we think of digestion. And you're not incorrect about that by any means, but you got to imagine the process of eating food. So just because you put food inside of your mouth, does that mean you're going to digest it? I hope you guys are starting to see what I mean. So when you put food inside your mouth, imagine a hamburger or, broccoli, whatever you guys prefer. What's going on with that food? What's the first thing that's happening? Break down immediately? Enzymes? No. Mastication? Good, but still not done. That's not the first thing that's happening. I'm just trying to get you guys to, be thinking about flowcharts and stuff. There we go, Tariq. Exactly. The very first thing that's happening is saliva. And actually, before that, there's a process of behavioral that is a whole outside of the realm of this classroom. But you got to remember that searching for food is not a given. The whole idea of hunger is not a given. How many times have we eaten when we're not hungry? Or how many times have we just had a craving, therefore we go and get food even when we're not hungry, right? Or how many times when we're hungry, we don't have access to food. So there's a lot more going on with the digestive system than just digesting, okay? I hope you guys can see how that would happen. But when we do start thinking about food, and when we do put food inside of our mouth, we are salivating. That's an awesome beginning to the story. You gotta salivate in order for, well, it's not 100% involved in digestion, but you can do it without salivation, but it's gonna make it really, really tough. So using that idea, right, now you guys can start to think about the processes of digestion a little bit better. We're salivating, we are digesting a little bit in our mouth, we're masticating in our mouth, we're chewing, our tongue is creating a bolus of food. Now, what's going to happen next? Aha, swallow. See how we're not just talking about digestion right now. We're swallowing. This is motility. This is the movement of food from your throat. From your oral cavity into your throat and then down your throat. That's not a given. There are a lot of patients out there that lose the swallow reflex. and they're not able to get food from the oral cavity down into their stomach. That, would, in my opinion, really suck. Now food gets in your stomach. What's happening down there? Breaking down acid. Yeah, but what's breaking down? See, this is a thing. What's it breaking down? Proteins. So what's happening to glucose? What's happening to fats? There's more in your food than just protein. You see what I'm saying here, right? There's a lot more. Nothing's entering the bloodstream yet. Nothing's entering the bloodstream yet. We're not there yet. No glucose is getting digested. So we'll get there. I'm just trying to get you guys to, think of these flow charts and think more outside of the box than just digestive systems about digesting. Does that make sense? Like each part of this digestive system is going to be unique. Each part of the digestive system plays a role, plays a function. And we need to think about each one because from the stomach, where's it going to go? Now it goes to the small intestines, but there's not just one part of the small intestines. There's actually three parts to your small intestines. And each part of those small intestines has a different name because structure determines function. And if each one has a slightly different structure, then each one has a slightly different function. And then from there, everything moves out into the large intestines. And guess what? The large intestines have a different function as well. And then from there, where does it all go? To the rectum, which is just a muscular storage container. Not out yet. It's not out yet. Okay, cool. You guys feel like you've at least got half of it? Because there's still a lot more to it. Because all you guys have even thought about so far is digestion. That's not true. Heather, was that you that said into the bloodstream? So one person actually still thought of, into the bloodstream. We can't just digest the food. We actually need to get it into the bloodstream. And that's not as easy as it sounds. So a lot of the physiology you guys are going to be learning is going to be related to getting that stuff into the bloodstream. So what I want you guys to do is I want you to take 4 minutes, 5 minutes, and I want you guys to try to finish this flow chart right here. So if we put food into our mouth and it goes into the oral cavity, don't worry about the stuff on the right. You guys will be able to do that over time. I want you to get it from the oral cavity down to the anus. And that's what the alimentary tract or the digestive system, the GI tract, is all about. Okay, it's one big long tube from mouth to anus with a couple of sphincters in between. It's the weirdest thing to think about ever. You'll never think about digesting food the same if you go that route. It's just one big long tube. So I want you guys to take the next, I guess, 4 or 5 minutes, 22 to 23 after. Ready, go. And just on a piece of paper, just start thinking through everything that we just said. This is basically going to be our anatomy review. And if you get it wrong, who cares? Just try to get through the system. Okay, let's see what we got, whether you finished or not. Oral cavity. Oral cavity is that inside of the mouth. It's got your tongue, it's got your teeth, has a lot of jobs. There's going to be a lot of little anatomical pieces of the puzzle that you guys are going to have to learn about. But the main ones that we're going to be dealing with are going to be teeth. I don't get to spend too much time on them, and I must admit I'm not an expert on teeth. It's not something that I've spent a lot of time studying at all. And then also within the oral cavity, one that we are going to focus on is going to be salivary glands. Salivary glands will be something that I like to test on, for sure. Now, as we swallow, this is all going to go back into the throat. And if you recall, the throat is the pharynx. But there were three different parts of the pharynx. There was the nasopharynx, the oropharynx, and the laryngopharynx. And yeah, you guys will need to be able to separate each one of those out. I'm not sure if anybody did or not, but there you go. It doesn't go into the nasopharynx, thank goodness. We don't want food going up into our nose. And that's why the uvula is there to help prevent it from going in the nasopharynx. So the first part of the pharynx that it goes into is the oropharynx. And from the oropharynx, it goes into that laryngopharynx. And then from the laryngopharynx, it's going to go down into the muscular tube that's called the esophagus. How's everybody doing so far? Did everybody kind of get at least something similar, even if it was just pharynx? I hope you guys didn't write throat, but if you did write throat, okay, it's a start. Make sure you know the word pharynx for throat, pretty please, and then break it down into the subcategories. Now, what you guys are going to learn is that for me, learning the GI tract is about making sure that you understand the entire flow of movement, but also how food's going to get from one place to the next and what prevents it from going backwards, because we only want food going forwards in this system. And there's some sphincters that are in the way. There's actually a sphincter right here between the laryngopharynx and the esophagus. This one here is called the upper esophageal sphincter. And I hope you guys can start to see that if I have a sphincter here, it's a muscular tube, it's a muscular ring that's going to normally be contracted. And when we swallow, part of that swallowing reflex is going to relax that sphincter, allow food to get through, and then it's going to immediately close again. Does that make sense? There's one right at the bottom. You can't really get to it very much, but there's a sphincter down there. I spelled sphincter. You guys, it's not sphincter. It's sphincter. Don't mind me. And I hope you guys start to realize how important this sphincter is, because if somebody's upper esophageal sphincter isn't working properly, which happens actually more than you imagine, and it's not relaxing, imagine trying to swallow food and it only relaxes a tiny little bit, or it doesn't relax at all. How's that going to go for you? Not good. Okay, so feeding tubes and stuff like that. So I always want you guys to think about, why do we care? Why is this stuff important? And I hope maybe I can make a little dent in that. Now, from the esophagus, this food is going to go down into the stomach. The stomach is going to have quite a few different components you're going to have to learn about, okay? From what's called the cardia, to the body of the sphincter, to the pylorus. So there's going to be quite a few different parts of the stomach you're going to learn about. So you're going to fill in the rest of this. But down below is called the pylorus or pyloric region. We'll show some pictures of it in just a second, but I like words first because you can't learn a language without learning the words, and it just doesn't work. Now there is a sphincter here as well. Why? Because think of the stomach. What's the function of the stomach? Man, it's going to be digesting tons and tons of proteins. So everything related to the stomach here is all about, well, not all about, but mostly about acid. There's going to be a lot of hydrochloric acid being produced by that stomach. And do you want that hydrochloric acid going backwards? Do you want hydrochloric acid up into your esophagus? No, thank you. So if there's an upper esophageal sphincter here between the laryngopharynx and the esophagus, what do you guys think is going to be down here? Yeah, the lower esophageal sphincter. However, there's another name for it that I want you guys to be thinking about, okay? And that is related to its body position. So the esophagus is right here. It's actually lower. Yeah, you can do, superior and inferior. That's fine. But what I want you guys to think about is what organ lives right here? What organ, besides the esophagus, what organ's right here? That's the heart. That's the heart. And basically, right where the esophagus passes through the diaphragm, that's where we find that lower esophageal sphincter. It's right there. It's going to lead into the cardia of the stomach. This is called the cardia. This is called the fundus. This is the body. This is the pyloric region of that stomach. But right at this point is this lower esophageal sphincter. Now I want you guys to think about what would happen if this sphincter was relaxed at any given time, other than when food is passing down. What's going to be leaving your stomach and going back up into your esophagus? This is called acid reflux, otherwise known as heartburn. This is why it feels like your heart is burning, is because your heart sits right over the top of that esophagus, that lower inferior portion of your esophagus. And so that's why this sphincter is also known as the cardiac sphincter. Okay, so lower esophageal sphincter works just fine, but I like to call it the cardiac sphincter because, it kind of makes me think about that function and where it's located. And if there is acid reflux from the stomach back into the esophagus, it's going to cause that heartburn, which, quality of life. There are people out there that everything else in their life is healthy, but they have serious acid reflux. That's a problem, right? It's all about quality of life. All right, so now down in the stomach, there's going to be a lot more to the anatomy of the stomach. One of the things is the regions, cardia, fundus, body, and pylorus. But there's a lot more going on down in the stomach we're going to get to. Don't worry, I'm not just flying through this and making you guys do it all on your own. We're going to get to it. We're going to see that stomach muscles are churning the food and that there are these crazy big gastric folds in here that look like a bald head. Motorcyclist going down the road without a helmet on, but a very, very bald head. There it is right there. This is where all the acid's going to be produced, and we're going to talk about how all this acid is going to be produced. So we're going to get to that. But from the stomach, all of this food that's been digesting is going to start to be released down into the small intestines. All right? The small intestines comes next. So from the stomach, we have small intestines. The small intestines are just named small intestines because their width is small, but they in and of themselves are not small. They're the longest portion of your digestive system. Okay, there's a lot going on with the small intestines. I would argue that the small intestines are the most important part, hint, hint, of your digestive system, hint, hint. If you had to give a most important role to one of these that we're discussing, it's going to go to the small intestines. The small intestines goes in the following order. Okay, it's going to go duodenum first, duodenum. Okay, that's how you can spell it, duodenum, but it's pronounced duodenum. 2, jejunum. Who came up with these names? Duodenum, jejunum. And the last one is the ileum. Oops, that's not. Why did I do a T there? And the last one is the ileum. Okay, the ileum is the longest portion of the small intestines, but it's least functionally relevant. In fact, the duodenum, right as food is leaving the stomach, this duodenum right here, this is your key player. Okay, this is the quarterback, the running back, and the kicker all in one. It's scoring all the offense for the most part. The duodenum is your star. Okay, and why is that? Well, it's only 10% of the total length. Of the small intestines, but it's going to account for over 90% of all digestion and absorption of all of that material. Sounds like a pretty key player, right? The duodenum's where it's at. All right. Now, from the small intestines, it's going to pass into the large intestines. And the large intestines has quite a few different portions of it as well, of course. The large intestines. We're going to start in the colon. Maybe you guys have heard of, colonoscopies before. Right? But it actually doesn't start directly with the colon. As it goes from the ileum, I should have done this in a different order. When it goes from the ileum, it's going to go into this enlarged portion right at the very base of the large intestines called the cecum. The cecum is where most of our bacteria is housed. Okay, this is kind of like, the warehouse, the reservoir of bacteria. And in fact, some animals enlarge their cecum on purpose. So what's going to happen to the number of bacteria in those animals? Increase. What does that help us do? Well, humans don't have a very big cecum, but something like a horse and a rabbit, those guys have enlarged cecums. What does that do? The bacteria can digest what they're eating. Horses can't digest that food. Horses can't digest cellulose. Animals don't have the enzyme to break down cellulose, not cows, not any animal. What they have is bacteria that does that job for them. And so if you enlarge the cecum, now you can break down more cellulose and you can get enough energy to grow as big as a horse. Crazy. Cecum goes into the first portion of the colon, and it's going to ascend. It's actually going to go all the way up. If you take your hand and start on your lower right abdominal cavity, way down next to your hip, that's where you find the cecum. And then the ascending colon is going to do exactly what the name implies. It's going to ascend. It's going to go straight up towards your liver. When it makes it to your liver, it's going to bend at 90 degrees and it's going to traverse all the way across to the left side of your body. So the next portion of that colon is called the transverse colon. Okay, it's going to bend at the liver and then it's going to transverse, also known as a horizontal colon, It's going to transverse all the way across, and then from there, it's going to drop. It's going to descend. It's going to, by the way, this makes it all the way to the spleen. And then it's going to make another 90-degree turn, and it's going to descend all the way down towards the lower left-hand portion of the abdominal cavity. So this is the descending colon. From here, it's going to actually take an S turn. And in Latin, S is sigmoid. So this is a sigmoidal colon before finally it makes this S turn. Like I said, that's where it's going to end up dumping everything into the rectum. And from the rectum, it exits the body through the anus. I would have gone back up, but I put all this blue text in here, so that's kind of a bummer. But let me put this back in the center. So let me go back through that again. From the mouth is just the mouth. It's not the oral cavity itself. The mouth is basically all that stuff before your teeth. From the mouth, as food passes into your mouth, right, it's going to pass through those front incisors and then enter the oral cavity, at which time we start to chew. And salivation is going to help to mix all that food up and start to digest a particular type of food. We're going to talk about that in just a minute. Then you go to swallow. As you swallow, a reflex is going to move the food into the oral pharynx, the laryngopharynx, relax this sphincter, food's going to pass into the esophagus. The esophagus is going to start to go through these wave-like peristaltic motions before passing the food down into the stomach. Whole bunch of stuff that you guys can add into this flow chart. The stomach is going to be digesting proteins because of all of its acid, and then there's also going to be an enzyme you're going to learn about. And the stomach is actually a beautiful reservoir as well. The way to think about this is you guys eat a gigantic meal. Do you want to digest all that food all at the exact same time? Do you want this huge bolus of energy going into your system, or do you want it to last over a 3 to 4 hour period of time? Kind of cool logic to think about. Maybe you never thought about that before. But you need your energy to last over a long period of time, and it's not your blood that's doing that. If you put energy into your blood, your body's going to use that energy or store it away long term. So what the body does is when you eat a meal, it stores a large majority of that food in that stomach. And it's only when your body needs more fatty acids, or when it needs more proteins, or when it needs more carbohydrates, that it's going to release that food from the stomach into the small intestines. By the way, I forgot to write one in. Gosh, there's a really important sphincter from the stomach into the duodenum, and it's called the pyloric sphincter. That's an important part of the story, Dr. H. That's what allows that stomach to be a storage container. If I have a sphincter that's tightened down at the bottom of that stomach, yeah, exactly. If I have a sphincter that's closed at the bottom of that stomach, now what I can do is I can keep it closed, keep it closed, keep it closed, and when I need to release more food into the small intestines, I open it for like 2 seconds, and then I close it again. That's it. It's going to pass what's called a bolus of chyme down into the small intestines, and then what's the small intestines going to do with it? Digest and absorb the nutrients from that meal. Does that make sense? All right, well, we'll come back because I just wanted to make sure to review the anatomy, the basic anatomy of the system. And then in lab tomorrow, you guys are going to have to find all of these different things. So let's dive into some of the physiology. And as we go through the physiology, what you're going to see is the physiology is going to relate to the anatomy. I'm just trying to keep that in context for you. So the very first thing we're going to be learning about with the physiology is what? It's going to be the oral cavity, right? We're going to be looking at what's going on with teeth and what's going on with salivary glands, and then what's going to happen with the swallowing reflex, and then how do we get food down from the esophagus into the stomach. That requires physiology to make it happen. Does that make sense in terms of the anatomy and the physiology? Help me so I can move on finally. Thanks, guys. All right, now again, all the anatomy is broken down here in the anatomy 1 overview. There's still 2 more things that I want to come on, pop-ups go away. Norton Live. 2 more things that I'm going to have you guys to look at in just a second. But I just want to now take what we just saw with the flow chart, and I want you guys to look at it here in this picture. And you'll see that if you're thinking about the words of your flow chart, it's going to make this a lot easier. Where does food go first? It's going to pass that mouth into the oral cavity. Oral cavity is an organ of your GI tract. From there, it passes into the throat, your pharynx, the oropharynx, then the laryngopharynx. Then, passing a sphincter, the upper esophageal sphincter, it's going to go down into the esophagus. From the esophagus, it's going to go to the lower esophageal sphincter, the cardiac sphincter, into the stomach, churn, digest, into the, what's this very first portion of the small intestine going to be called? Go ahead and write it in chat. Good, that's the duodenum. And it's going to pass through the pyloric sphincter, which is part of your stomach, to get into that duodenum, which is the first part of your small intestines. Good. And then, I'm not going to make you guys just, I'm not going to point a random arrow in all of this mess here and say which portion is the jejunum and which portion is the ileum. But if I put an arrow way up here and it's real close to the duodenum, this is going to be the jejunum. And if I put an arrow way down here next to the right side of this patient, this is where that cecum is going to be, then this would be the ileum. That's the end of the small intestines. From here, it's going to pass into that cecum, ascending colon, transverse colon, descending colon, sigmoidal colon into that rectum. Does that make sense based on the flow chart that we wrote? Awesome. Remember, I am not trying to tell you guys that flow charts are the only way to learn. I never said that. You got to use flow charts in conjunction with a picture, in conjunction with diagrams, with formulas. And when you do them together, it makes it easier to understand. Because hopefully now you guys, since you did the words first and you're like, Dr. H, I can't picture what the hell you're talking about. I'm just writing down a word. I don't understand what's going on. But then when you switch to the picture, wasn't it a little bit easier to understand each portion of that? In my opinion, and in my experience, the answer is yes. But you got to be willing to do the flow charts with me as you go. Don't get bogged down in all the words. Now, we're going to write down the physiology of the digestive system. And we're going to summarize the physiology of the digestive system in 6 processes. And we're going to go back to that picture one more time. 6 processes. The first process is just getting food in your mouth. Okay, that's a pretty big deal, and it's called ingestion. In, as in putting food inside of your mouth. Ingestion. Getting food into your mouth is a pretty big deal. Again, there's all sorts of behavioral psychology, physiology involved in the ingestion of food. Don't take this for granted. A lot of disorders of ingestion. But once you get that food in your mouth, now we get to start to chew it. Saliva's present. So we're going to start to digest it. It's a pretty big part of the digestive system, obviously, but it's not the only part. Now, with digestion, what you may have noticed me saying is chewing versus saliva. Those are actually two different types of digestion. One is called mechanical digestion. Chewing is mechanical. Okay, your blender system, right? You're literally chewing up that food. That helps a lot with digestion because we can't get chemicals into the center of food unless we mix that food and chop it into tiny little pieces. But once we get a lot of mechanical digestion, this is going to be occurring in the mouth by chewing. It's also going to be occurring in the stomach, and it occurs in the small intestines. Mechanical digestion is occurring all over the place. But once we have all this mechanical digestion, then we can start to digest it with chemicals. So there's mechanical digestion and there's chemical digestion. And chemical digestion occurs inside that mouth too, because of saliva. And we'll learn about why. 3. You're chewing, then you swallow. Swallow is its own process. But it's not just the act of swallowing. It's actually moving the food through the esophagus, moving it through the stomach, moving it through the small intestines and large intestines. Again, not something you want to take for granted. What if you move things too fast? Good, Heather. What if you move things too fast through your digestive system? How's digestion going to go? Increase, decrease, no change. If you're moving it so fast that enzymes don't have the ability to act. Good, decrease, yeah, decrease. Okay, you're not going to digest the ions properly, therefore you're not going to digest water properly, and you're going to be shatting out a whole bunch of water, ions, and nutrients that you should have digested. This is called diarrhea, okay? Lots of spastic colon issues with increases in what's called motility. So the motility is what comes next, motility. And the primary way that we move, motile, right? The primary way that we move materials through the digestive system is with peristalsis. But it's not the only way. Peristalsis. There's also something called segmentation, which fits a little bit into the mechanical digestion as well. And then mass movements, which occur down in the large intestines. So all 3 of these are different types of motility, and they're all going to be controlled by smooth muscles, muscles that are going to be contracting and relaxing. What else do we have going on? This is a tough one. It doesn't really matter what order you do these in, by the way. Yeah, hydrochloric acid acting on it, but how did we get hydrochloric acid into that stomach and to begin with? How are we getting the saliva into our mouth? We got to make that stuff first, don't we? No, I'm not just talking about swallowing, Tariq. I'm saying, hydrochloric acid's not coming down through the laryngopharynx by any means. I think it's important to try to remember, that physiology happens at the cellular level. Goblet cells, no, goblet cells are for mucus. There's other glands for everything else. But we got to remember that things happen at the cellular level. So what's going to end up happening is cells need to make it. whether it's saliva, whether it's mucus, whether it's hydrochloric acid, or whether it's the enzymes that go in and help to digest the food. It's got to make it, and then it's going to move it into the GI tract. This is called secretion. Secretion is going to be one of the ones you guys end up probably hating the most. It's difficult to think about how secretion works because we're going to have to think about the cell itself, okay, whether it's a simple cuboidal cell or a simple columnar cell or whatever it might be, and moving materials from that cell out into the bloodstream, or not into the bloodstream, what am I talking about? In this particular case, out into the lumen of your GI tract. Okay, so this is the GI tract over here. This is a cell in here, right? Where the cell is going to be making that material and it's going to be moving it out into the GI tract. That's called secretion. But what about the opposite? Now that we have food, it's getting digested by secretion of all sorts of stuff, right? Saliva, enzymes, hydrochloric acid. These are all the properties that are going to help us digest that food, mucus. But now that we have digested that food, what do we need to do? Let's go, guys. What do we need to do? We're just going to pass it out in our feces? We got to absorb it. Great, Becca. Does that make sense to everybody? We can't just digest it. We can't just have secretion and movement of material. Listen, you're going to be adding about 1.5 liters of saliva into your oral cavity every day. 1.5 liters. Hydrochloric acid, you're putting in about 1.5 liters of hydrochloric acid into your stomach every single day. Mucus, you're adding about 7 liters of mucus to the system every single day. So just do the quick math on that. That's like 12 liters of material. That's 6 2-liter Coke bottles side by side. And are you shatting out 6 liters? God, I hope not. Are you shatting out 6 liters of food every single day? Of water? No, not even with diarrhea, but I mean, it gets, yeah. Do you see what I'm saying? We can't just be adding things to the system. We got to take things out of that system. Yes, no, maybe so? It's critical part of this, which is absorption. And it's going to be what we end up talking about on Thursday, is absorption of that material. In order to absorb things, we're going to be taking material from, use this, from the GI tract, right? We got the GI out here, and we've been digesting and taking care of stuff. Well, now we need to move it back into the cell. Okay, that's absorption. Moving things out of the cells to help with digestion is called secretion, moving material back into those cells, and then from there, it's going to have to go into the bloodstream. This is called absorption. Make sense? You're putting about 12 liters into the system every single day. Well, you're only going to end up pooping out maybe 0.5 liter. So that means you've got to absorb about 11.5 liters of all of this material that's going in. That's crazy and really cool. Last but not least, we are at the end of the road now. Now we get to excrete it all, and this is called defecation. So these are the major 6 processes of the digestive system. Everybody have those written down? Okay, because now comes the tricky part. The tricky part is for when you guys go to study. Because what you need to be doing is for each part of the GI tract, we haven't even talked about the accessory organs yet. Well, I guess we kind of have salivary glands, teeth, but the GI tract, for each portion, I want you guys to tell me which processes are occurring there. So for instance, in the oral cavity, which of these 6 processes are occurring in the oral cavity? Mouth, oral cavity, you can add it all together. Ingestion, sure. What else? Which part of digestion? Mechanical, yep, because we're chewing, moving that food around. But what else is going to be happening? Chemical digestion too, in the form of saliva. Right? What about secretion? So if we have saliva, then we had secretion there, didn't we? Is everybody kind of following along in how to study each one of these? Everything that you guys do here, oral cavity, which process occurs there? Ingestion, both mechanical and chemical digestion, and secretion of saliva. You're going to find that, motility, you're moving your tongue around and whatnot, but the swallowing process doesn't occur until it makes it into the pharynx. There is no absorption of anything in the mouth ever. And of course, I hope we're not defecating from our mouth, so we should be good there. See what I mean, jelly beans? So now, pharynx and esophagus. These ones are really straightforward. We don't ingest there. We don't need ingestion anymore. We're not digesting there. We're not secreting there. We're not absorbing there. We're not defecating there. The only thing that's occurring there is motility. It's a passageway to get it from the oral cavity down into the stomach. Make sense? Awesome. You guys are rock stars. I love it. Now, you guys can do each one of these. Stomach, man, a lot going on in the stomach, both mechanical, chemical digestion, churning of that stomach, secreting massive amounts of mucus, hydrochloric acid. We do start to absorb a few things in the stomach. If it's lipid soluble, it can start to be absorbed here in the stomach. Not a lot of it is going to be absorbed, a little bit. And this is how we can get these gastric absorption in some of our the drugs. So we give patients, we can actually give them capsules that are absorbed here in the stomach rather than having to go through the rest of the system, and it increases the speed at which those drugs can work. So there's some understanding of the stomach and absorption in the stomach that I won't really test you guys on thoroughly. All right, small intestines, large intestines. These guys are primarily about moving the material and chemically digesting and absorbing, and then of course secreting massive amounts of material yeah, we'll talk more about those later. And then anal canal, there you go, defecation. That's the end of the road. Now, here's the good news for y'all. I've already started to set this up for you by, pulling this picture out of a textbook. So in the mouth, pharynx, salivary glands, esophagus, each one of those, like what's happening in here? There you go. Okay? In terms of the processes that are organized. Stomach, large intestines, small intestines, anus, rectum. So as you guys go through it, it's already taken care of for you, color-coded and all that jazz. Exactly. Awesome. All right, the last part of the digestive system is outside of the GI tract. The GI tract is literally just that. It's a tube from mouth to anus. But it's not the only thing involved in your digestive system. For instance, teeth, tongue, salivary glands. They are adding to the system. They're not part of the tube. So these are called accessory digestive organs. But there are 3 major players in the digestive system down in the abdominal cavity that you need to know about. The liver, the gallbladder, and the pancreas. Your bridesmaid, your bridesmaid's personal assistant, the gallbladder, because every bridesmaid needs one of those. And then the best man's over here, the pancreas. What does this mean to be an accessory? It means that they play a huge role in digestion, but they're not part of the tube. So each one of these organs is making something or secreting something that's going to go into the GI tract. That should stand to reason, right? So let me help you guys out. So if I write over here, I write liver, I write gallbladder. Those kind of go hand in hand, by the way. Those go together. Gallbladder helps with liver function. It's not required, but definitely helps. And then I got the pancreas. Each one of these is going to have a tube, a duct that leads away from it and enters the digestive system. What part of your digestive system do you guys think all of this material from the liver, gallbladder, and pancreas is going to enter? There's one part. It is part of the secretion. That's one of the processes, but I'm asking anatomically, what part of your digestive system seems like it'd be the most important for helping with digestion and absorption of materials? Yeah, you got it. Not just any old small intestines, y'all. Not just any old small intestines. Andy got it spot on. It's all going to get dumped into that duodenum right there. Okay, liver is secreting bile. Bile helps with fat digestion. Boom, right into the duodenum. Gallbladder is a storage for bile from the gallbladder into the duodenum. Pancreas, all of literally what's called your digestive juices. Makes you thirsty, right? Digestive juice. I ain't even joking. These are called juices. Just like inside your stomach is gastric juices. Nummy. Pour yourself a nice big glass of digestive juice. All of that gets dumped into that duodenum as well. Maybe starting to emphasize the importance of the duodenum to you all. Okay. Yeah, yes and no. Yep, exactly. The gallbladder, it's just a store. Think of it like I always use this analogy, so this is a good one to use. Think of it like a turkey baster, right? It's just a turkey baster. You can still have a pretty damn good turkey without the turkey baster because you could, use something else. You don't have to have the turkey baster. But that turkey baster, if you squeeze that turkey baster ball, it's going to squirt stuff out from that bulb at the end. True story? And when you relax that bulb at the end, it's going to suck juices back up into it. Why? Boyle's law. What do we know about Boyle's law? Volume and pressures are inversely related. So literally, you're just creating this little vacuum in your gallbladder, and it's going to suck bile up into it, store it until you need it. When you need it, it contracts, squirts stuff out. But it doesn't mean that the rest of the system can't still do its job. You'll see what I mean when we get there. Okay, let's see here. Cool. Spent a lot of time over this, but what I want you guys to be able to do is when you go through the anatomy overview by yourself, is that's all you're doing. You're going down system, you're going to look at your lab objectives at the same time, and you're going to find what you need to find from your lab objectives. So as you're going through the oral cavity, only focus on what's on your lab objectives. Is that clear? As you're going through the structure of the teeth, focus on what's on the lab objectives, which is quite a bit of this. Crown, enamel, dentin, pulp cavity, root canal. I love the names because if you've ever had work done on your teeth, you tend to already know these names. And now you might know where they come from. For instance, if you have a root canal, well, the root canal is literally a portion of the tooth where your blood supply and nerves enter, exit that tooth. The tooth is a living, beautiful beast. This is a creature in and of itself. It's alive, just like your bones are alive. So if you have a root canal, for instance, if you have a patient who has inflammation that's causing pressure to get put on the nerves, you're going to get massive tooth pain from that. In fact, it's one of the worst pains the human body can have. Bizarre. Tells you the importance of the teeth if we have that many important nerves going to your teeth, by the way. But yeah, root canal, gingiva, gingivitis, gingiva, right? Gingivitis means inflammation of the gingiva, which means inflammation of your gums. The large majority of your tooth is made up of something that's a little bit like bone, called dentin, but it's harder than bone because it has more of the material that makes up that hardness of your bone, called hydroxyapatite. Anyways, go through that. The different salivary glands, these are definitely going to be part of your lab objectives. So you got to be able to identify your parotid, submandibular, and sublingual. We'll do those tomorrow together as well, kind of teach you how to palpate them and whatnot. But can you guys see that basically I'm just going through the different oral cavity structures? And then here I am in the next slide, which is once you're out of the oral cavity, where's it going to go next? Into the throat. Yeah, we did lose the lab day. Tomorrow's going to be tight. So it's going to go down into that throat. Oral pharynx, laryngopharynx. There's going to be an upper esophageal sphincter right here. Boom, down into that esophagus. Make sense so far? We'll deal with the different layers, the histology of the system. We'll deal with that tomorrow in lab. Just a muscular tube, super easy, passes down from that upper esophageal sphincter to the lower esophageal sphincter. Muscular tube. Esophagus is crazy easy to understand, down into the stomach. So finally, what we're going to do is we're going to kind of switch back and forth to some of these, and we're going to walk our way through the system. I've already started this for you. All the studying that you need to do for the digestive system, we've started to think about. But there are certain things that you guys need to get focused on because students don't really, know to look at like these images here. It's pretty crazy for students to think about. So what I want to remind you guys of, everything we do is going to be based around these 6 processes. So if you guys go to study, how can you start? 1, flow chart of the anatomy. And 2, always write down the 6 processes. So now when we start going through the rest of this, you're going to have those 6 processes in mind, and we're going to be starting with the oral cavity and then working our way through that system. Even when it comes to the different phases of digestion, we're going to be starting with the oral cavity. We're going to be starting with the head. So physiology, let's get started on it. There are 3 major phases of digestion. The first phase is called the cephalic phase. Cephaly, right? This means head in Latin. So the cephalic phase means the phase related to the head, which includes everything from seeing food, smelling food, hearing the sound of food cooking. And then in addition, placing food in your mouth, chewing, and swallowing. So if it is related to the head, whatever case that might be, taste, I forgot, you know, got to taste that food and make it really good. But if it's related to the head, it's called the cephalic phase. Clear? The next phase is the gastric phase. Gastric simply means stomach. So if it happens in the stomach, it's part of the gastric phase. From the stomach, it passes into the small intestines, from the small intestines into the large intestines. So the last phase is the intestinal phase. Okay, each one of these has a specific role in your system. But something I want to point out now is that your digestive system is extremely intelligent. The digestive system actually has its own nervous system that nobody ever teaches about, even in A&P 1. It's called the enteric nervous system. It's like the central nervous system, but it's for your digestive system. Your digestive system has its own brain. It's called the little brain. A lot of people that work in the digestive world call it the little brain. Now, can the big brain still control the little brain? Of course. But can the little brain have a lot of control over the big brain? You guys all know this, right? Can that stomach of yours, can those intestines of yours play tricks on your big brain? Are we all the perfect eaters in the world? Do we all have to really consciously be aware of what's going into our mouth every single time we, I mean, yeah, is the answer, right? There's a lot going on in this system. The communication between these systems is insanely complicated, from nervous control to hormonal control. There's a lot going on with communication. So if we start with the cephalic phase, think about what's happening inside that oral cavity. We're chewing food and we have saliva. So we have chemical and mechanical digestion. This is also where ingestion occurs. It's just not one of my bullet points. This is where mastication occurs, which means chewing. So there's quite a bit going on here, but what I want you guys to focus on for your exam is salivary secretion. It's going to be the major one that I end up testing you guys on. So what exactly is going on with saliva? And I think, honestly, let's go ahead and skip these bullet points right now. I'm going to come back to this in 4 minutes. What I want to do is I want to come down to these salivary glands. We have 3 major salivary glands, actually 4. There was a 4th that was just identified last year, so oddly enough. We're still figuring out anatomy all the dang time. But there's actually a 4th one that was discovered in the nasal, the nasopharynx, that had never been discovered before. I'm not going to deal too much more about it, but kind of makes sense that you need to have some saliva and some mucus that's produced in the nasopharynx. But yeah, it's pretty cool. If you guys want to talk about it, I can talk about it with you guys individually. Parotid, this is one you can palpate. Just take your hand, place it just anterior to your ear. That soft, fleshy tissue right there is your parotid salivary gland. Lingual. If you're bilingual, you can speak 2 tongues. So lingual actually means tongue in Latin. Not language. It means tongue. Sublingual salivary gland lies underneath your tongue. And there's a duct that comes up from underneath your tongue out into that oral cavity. Anybody know what gleeking is? My brother used to gleek on me all the time. I don't know. Yes, no? Gleek? Gleeking is when somebody, it's not spit. It's almost grosser than spit, honestly, but it's not as bad as spit because spit comes from the oral cavity mixed with tons of bacteria and all that stuff. But um, it's where they can depress their tongue and actually puts pressure on this sublingual salivary gland, and it causes a stream of sublingual saliva to go shooting out of that person's mouth. My brother used to be able to hit me from 10 feet away. It was ridiculous. He was like a spitting cobra. Bastard. You probably actually can, if you sat and you learned how to depress your tongue downwards, and I can't really, I used to be able to gleek sometimes, but it's just too gross for me. I'm not going to teach my kids to do it, so. All right, I know, fun little thing, but that's not what we want to focus on. Sorry. Submandibular salivary glands. They've cut away the mandible so you can see it a little bit better, but it's just right. You can palpate your own submandibular salivary glands if you actually go up underneath your mandible on the lateral aspect. There's going to be a salivary gland there as well, and a duct that kind of enters the system into the oral cavity. So, cool. Now you guys know the anatomy of it, but most importantly, in my mind, is the composition of saliva and how we regulate salivary secretion. So again, about 1.5 liters of saliva is produced every single day. 1.5 liters of spit, y'all. There's a couple of reasons why I want you guys to pay attention to that. What if you have somebody that has an inability to swallow? This spit's got to go somewhere. One, they're not eating very well. Two, this is water that their body is producing. It's secreting this into their oral cavity. And if they spit out 1 liter to 1.5 liters of saliva every single day, what's going to start happening to their blood volume? Increase, decrease, no change. Does that make sense? I think I might even mention that back in our blood volume stuff, but yeah, I mean, saliva is 99.5% water. It's almost all water. And then you start adding some things to it. The primary one you guys need to know about, you must know about salivary amylase. You must call it salivary amylase, not just amylase. What salivary amylase is it's an enzyme that digests carbohydrates. And not just any carbohydrates. It digests starches. I hope you guys recognize that word, starch, right? A real starchy food like potato, like noodles. Amylases, all amylases digest starchy foods. Complex carbohydrates are just big, long chains of glucose. Glucose bound to glucose, bound to glucose, bound to glucose. Huge chains of glucose. And if we start throwing some amylase at those carbs, those complex carbs, that starch, then it's going to start to break it down into glucose. We immediately start digesting for glucose in our oral cavity. Probably starts to tell you how important glucose is to the human body. Yes, no? Crackers. Who's ever looked at a cracker and said, no thanks, but then you eat that cracker and you're like, damn, I forgot how good these are. Like, especially saltines. Saltines are like, no, no. And then you take a bite and you're like, no. And then you start to chew it and then you're like, Oh, wait, these are actually kind of good. And the more you chew it, the sweeter it gets. And the reason why is that crackers, you got some complex carbs in there, and your amylase is able to digest those immediately, turning it into glucose, which now changes it to that, well, glucose pleasure system. So that's why crackers start to get pleasurable the more you chew them. Salivary amylase. Salivary lipase, the enzyme that helps to start breaking down fats. Now, here's the deal. Is these salivary lipases are secreted in the oral cavity, but they are not active yet. They are activated once they go into the stomach. They're not active yet. What's this one right here? What did I just highlight? I'm just waiting for a few more people. If you don't know this is bicarb yet, then you've got to just sit down and write it down 1,000 times. You got to Bart Simpson the crap out of that. I need to learn bicarb. I need to learn bicarb. I need to learn bicarb. You must know carbonic acid. You must know bicarb. In my class, you got to know them, okay? So if you're not recognizing this as bicarb yet, work on that, pretty please. Dealio? Yep, you got it. You got to know that. Everybody pretty please. From the deepest, bottomest part of my heart there. Guys got to know this. So what's so cool about bicarb? It's a buffer. And it buffers against acids. And when you eat food, you're eating acid. So we're starting to protect our body against acids right now. Lysozymes, antibodies, we're starting to fight against the world around us, breaking down, tagging things, trying to get those bacteria and viruses out of our body ASAP. Salivation. Everybody salivate. Doesn't work so well, does it? So, what part of our nervous system is going to control an involuntary function? And Tariq, you do that through the entire semester. You're jumping to the specific nervous system. Not a bad thing, buddy. But yeah, I'm just asking what nervous system, what part of your nervous system is going to be autonomic, is involuntary? And then what do you guys think for salivation? Rest and digest or fight or flight? Got it. Yep. So parasympathetic nervous system activates that secretion. And what the sympathetic nervous system does is it actually stops the secretion by stopping water. It's really cool. But now when you get super duper scared, anybody ever been so scared that their mouth just dries up? You start getting that smacking. There you go. That's why the sympathetic nervous system completely inhibits salivation. So if I go over here and I start thinking about this, well, where does this all come from? The medulla oblongata. There's a salivary nuclei in there that can control the parasympathetic nervous system and the sympathetic nervous system effect on salivary glands. And if the sympathetic nervous system were to activate, boom, norepinephrine gets released on the beta-1 adrenergic receptors, activates cyclic AMP through the adenylate cyclase process, everything you guys have already learned about. That cyclic AMP works on PKA, protein kinase A, and that goes and inhibits the production of saliva. Super straightforward, something you guys already have learned about. Parasympathetic nervous system is a fun one. Again, fear, that's going to inhibit parasympathetic. We already know that. Now, sleep is a fun one because sleep inhibits the parasympathetic nervous system's function on salivation. Do you want to drown in your own saliva while you're sleeping? No. So we inhibit saliva production. And some of you are like, wait a minute, Dr. H, I've fallen asleep many a time and woken up in a pool of my own saliva. I don't know if that naturally is something you're thinking, but you guys know what I'm talking about when you fall asleep and yeah, you're drooling. Yeah, that's just different levels of sleep. And kind of depends on the person. You're not going to have that sort of sleep every single night where you're drooling out, all over your pillowcase. Dehydration, of course, is going to inhibit this as well because dehydration loses water. Now, I just want to point out these three things. We're almost done. Obviously, food. If you see, smell, hear food, you can start to salivate. There's smell down there. Conditioning. This is the Pavlov's dog thing, right? If you are conditioned to eat at a specific time during the day, or if you're conditioned if you smell a particular type of food or whatever, hear a sound like Pavlov's dog, then you can start to salivate. That simple. But I want to point out this nausea one. Is anybody ever gotten nauseous and you start to salivate more and you're like, what the hell is going on? I don't know if anybody actually has paid attention to it, but I know every semester I hear a few people that are like, oh man, I've always wondered this. As you get nauseous, it hyperactivates the parasympathetic nervous system. What would be the advantage of this? Why would nausea cause parasympathetic activation of saliva? Nice. Not just your teeth. So Parker's spot on. What do we got going on here? Is it just salivary amylase? Is it just lipase? Is it lysosomes and antibodies? No, what else is coming out in your saliva? Bicarbonate. And if you vomit, what's coming up from your stomach? Hydrochloric acid, HCl. And if that hydrochloric acid makes it into your esophagus, back of your throat to the pharynx, the oropharynx and the laryngopharynx are very sensitive to acid and into your oral cavity. Then that acid is going to, yes, you got it, digest those proteins of your body. And your teeth, the enamel on your teeth are extremely sensitive to acid, which is why drinking Coke is so bad for your teeth, because Coke has a pH of about 1.5 to 2. So it's almost as strong as hydrochloric acid in terms of its acidity. HCl is an extremely strong acid, one of the strongest known to man. Okay, it's a pH of 1. And so the bicarbs are there to act as a buffer. They help to bind up excess hydrogens. We'll talk more about this at the end of the next unit, because we'll be talking about the urinary system. And just, I guess, to finish this all off, I want you guys to see some images of, the throat of somebody with bulimia, or the teeth of somebody with bulimia. You guys know what bulimia is, right? Where you're inducing yourself to vomit. It does some really horrible things. You got to imagine that you're inducing so much acid that your body can't possibly keep up with the buffering. Here it is. So this is what acid will do. Oh no, that's rheumatic fever. Where is the bulimic? Bulimia will actually rip up the back of your throat as well, completely cause degradation of your teeth, just like you see here. Completely just rips teeth apart. That much acid. If you pull a tooth out and you put it in a glass of hydrochloric acid, it'll dissolve completely within a couple of days. So I'm kind of going fast because time limitation stuff. Here we go. Bulimia nervosa. Look at the back of that patient's throat. Look at their gingiva. Look at their teeth. It makes you guys hopefully be a little bit more sensitive when you see a single word like bicarbs and, you know, try to link it together. I'm here to try to help you do that. But you're going to come across many, many more diseases in your future that you're going to have to link together with the physiology and anatomy that you've learned about. All right. I'm done. And I will see you guys tomorrow. Tomorrow, digestive system will continue. We're going to keep working our way down through the system. We'll spend a bit of time on digestion in the stomach. And then the hope is by the end of tomorrow, we'll have finished up this part of this lecture and moved on to the second lecture. I'm hoping, because I don't want to have to pile it all on you guys on Thursday. Don't forget, homework is already going to be due this Saturday. So if you haven't started your homework, you need to get started on it. Exams are already on Sunday. I'm finishing grading 4th of July weekend, just kind of, you know, grading wasn't as, well, I didn't get as much time to finish as I wanted to. So I will finish up probably today or tomorrow for the last set of exams. If you have any questions, give me a holler. You're welcome, guys. Anytime.